All right, so today's lesson deals with percent change problems. I know a lot of times you guys ask me, like, what does this have to do with real world math? Well, today's lesson is very applicable to real world math. We deal with percent change problems a lot. If you've ever gone to a store and you've seen that there is a 30% off sale, that's a percent change problem. Or you go to the store and you buy a 99-cent candy bar and it's not really 99 cents. That's because of tax. Tax is a percent change problem. So percent change happens frequently in real life. And to solve percent change problems, we can set up a ratio box. We've dealt with ratio box problems before where we have had part, and total. Right, so let's say that we've got three categories. We've got a percent, and we've got our actual counts. Some problems we've dealt with in the past. Let's say 80% of students passed the test, and 10 students. Let's be optimistic. 2 students failed the test. How many students were there altogether? So in the previous problems we dealt with, we got part, total. So those that passed, those that did not pass, and then a total. With these types of, let me get it more centered. With these types of problems, our total has always been 100%. So you've got 80% passed, 100% is the total. Well, if 80% passed, that means 20% didn't. And then I think I asked for how many are there altogether, right? So we're trying to solve for that mystery number, the total. So we can set up a ratio box. 20 over 100 equals 2 over n. Well, we can very quickly reduce that to 2/10. We don't need to reduce it further because we got a constant factor. 2 times 1 is 2. So 10 times 1 is 10. So how many students were there altogether? 10. And then if we wanted to, we could figure out that how many students failed, how many students passed, either 10 minus 2 is 8, or 8 times our constant factor of 1 is 8, and then 8 plus 2 is 10, right? So we've dealt with percent problems that involve a total. Now we're dealing with percent change, and things are a little different for percent change problems. So let's take an example. You're at the store and you see an item. So let's say you see your PS5, because hopefully that's coming out soon. Your PS5 is priced at $500. I imagine they're pretty expensive. Okay. But they come on sale, and they're on sale for 20% off. Exciting, 20% off. So we want to know, what is the new price? We can set up a ratio box to solve this problem. So same setup. You're going to set up your ratio box into 3 categories. Still going to have percents and actual counts. Here's where things get different. In the previous problem, we had the total down here. Well, we're not even going to have a total now. Instead, we're going to have an original price, the amount of change, and a new price. So here's where it's a little different. We're going to have the original up top. We're going to have the amount of change, either plus or minus. In this case, it's sale, so it's going to be minus because it's going to be cheaper than the original. And then we're going to have the new price. So with these types of problems, you can pretty much always set up the original to be 100%. So in the previous problem, we had 100% on the bottom. In this one, we have 100% in the top. Okay, and it's on sale for 20% off. There's a key word there. Off means it's 20% less. So it is 20. So I'm going to show that 20% off with minus 20, which means that the new price was 80% of the original. Original plus or minus the amount of change gives you the new percent. And then we got one more number. We need one more number to solve a ratio box problem. So we've got $500 here. So the PS5 is originally $500. So that matches up here with the actual count. So I want to know how much the new price is. How much are you going to, not how much are you going to save, but what is the price after the 20% savings? So for right now, we actually don't need the percent change. We need the new price. So we can set up a ratio box. 100% is to original is to new, 80, as original price, 500, is to new price, question mark. Nice thing here, you could reduce that if you want, but we've actually got a nice constant factor already. It is times 5. So we would take 80 times 5. 8 times 5 gives you 40, plus that extra 0 gives you a new price of $400. So with it being 20% off, you would have saved $100. And we can check that. Our constant factor was times 5. 20 times 5 is 100. So we take 100 from the original price, and we get a new price of $400. Pretty good savings. All right, let's look at another problem. Let's this time look at a percent increase problem. All right, so let's say you're at the store and you want to buy a $10 dress, and that dress has, let's say it's a pretty hefty tax. Let's say that dress has a tax of 10%. That's a little absurd. Let's say 5%. All right, so a tax is going to be an increase. So let's set up our ratio box. Always 3 categories. So split it into 3 categories. Our percents, our actual counts. Same idea over here. Original. The amount of change, either an increase or a decrease. Increase would be something like tax or a markup, a wholesale. Decrease would be like a sale, percent off. And then we're going to have our new. So again, with these types of problems, pretty much guaranteed that 100% is always the original. Okay, and we actually don't even need this percent, because what we're doing when we turn it into a ratio is we are getting rid of the percent and turning it into a fraction. All right, so the tax is 5%. That's an increase. So that's an increase of 5%. So our new percentage, 100 plus 5, is going to be 105%. And then the original cost was $10. So we want to know the new price. So again, we're not worried about the percent change. That's not always the case, but in this case it is. So we'll set up our ratio box. Set up our proportion. 100 over 105 is equal to 10 over our mystery number. Okay, and again, we've got a nice constant factor. In this case, it's divided by 10. 110 is divided by 10. So we take 105 and divide it by 10. Do your shortcut. Move the decimal one place to the left. So our new price would be $10.50. So not too bad. 5% tax on a $10 item gives you $10.50. So our tax rate was 50 cents, or $0.5, which is half a dollar, which is 50 cents. So let's do one more. sometimes you'll be asked to find the percent change, and sometimes you might actually be asked to find how much off was something. So let's look at that type of problem. Let's say you bought something. Let's say you bought a bike. And let's say your bike was $100 originally. Okay? And let's say it was on sale. And the cost of that bike was on sale, and the cost was now $70. We could use this information to figure out what percent off was it. Same idea. Set up your ratio box, 3 categories. Little skinny ratio box this time. You've got your percents, your actual counts, your original, your percent off or your percent increase, and your new. Okay, so plug in our information. $100 is the new, is the original. My apologies. And we want what percent off was it. So we actually don't have this number right here. But we do have the original price, which was also $100. We have the new price, which was $70. And then we are trying to figure out the amount of change. So we want to know what percent off it was. So to do this, we actually need some additional information. And to find that additional information, we can use the original and the new. So if it was $100 originally, $70 on sale, that means you saved $30. Now we have enough information to solve. So we can say 100 over n equals, and I didn't pick a great example here, but that's okay, 100 over 30. So here, these are actually equal. There is a constant factor of times 1. So 30 times 1 equals 30. So what percent off was it? It was 30% off. So you can solve for the original or the new price. You can solve for the original or new percentage. You can solve for the percent off. You can solve for the amount off. It just depends on what information you're given. Just remember, you've got to match up like amounts with a ratio problem. That's why with this one, we had to do some intuitive thinking and figure out how much off it was, because without that, we couldn't set up a ratio in which like amounts matched up. So using ratio boxes to solve percent change. I hope that helped.